Welcome to the 13th installment of the Kategos podcast. I'm your host, and today we are opening the technical blueprint on our landmark research paper, Architecting Categorical Intelligence, Resolving the AI Value Paradox via Sovereign Agentic Orchestration. Enterprise deployments have hit a hard architectural wall. Massive capital is flowing into AI, yet production returns remain stalled by volatile token costs, probabilistic hallucinations, and a total lack of executive control over autonomous agents. Here, we solve this structural ceiling. We don't wrap consumer chatbots in fragile SaaS middleware. We build strategy-led sovereign infrastructure. Operating natively in your private cloud, our sovereign virtual operating system abstracts and secures cognitive compute through multiple patent-pending technologies. The citation enforcement kernel, which mathematically eradicates hallucinations through deterministic verification, and the margin-based inference router, which flattens token spending while reducing AI data center energy consumption. Today, we are laying out the blueprint for turning your organization into a fully governed super agency. Let's head straight into the engine room.
Imagine you're signing a check to double your company's artificial intelligence budget for the year.
Right, which everyone is doing right now.
Exactly. You're expecting this absolute revolution. You are bracing for autonomous workflows, plummeting operational costs, and just a massive, undeniable spike in productivity across every single department.
You're waiting for the magic to happen.
Right. You make the investment, and then, 12 months go by. You look at the production stage economic returns, and they are completely, stubbornly stagnant.
Yeah, flatline.
You haven't revolutionized anything. You've just made your existing processes slightly more convoluted and, honestly, infinitely more expensive.
It's the classic trap.
I mean, you've essentially bought a fleet of Formula One race cars, but you're forcing them to drive in bumper-to-bumper traffic on a dirt road.
That is a painfully accurate way to put it.
So, today we're looking at a 2026 research-led white paper. It's titled Architecting Categorical Intelligence, and it claims to have the blueprint for paving that road. Our mission for this deep dive is to really understand how the modern enterprise is moving past generic, unreliable AI chatbots, right? Moving into this era of rigorous, mathematically audited, autonomous execution.
And that Formula One analogy, it perfectly captures the frustration sweeping across corporate leadership right now. I mean, the expectation of what artificial intelligence should be doing, it simply isn't matching the reality of the corporate balance sheet.
Not even close.
No. And the authors of this paper, they define this exact dilemma as the AI value paradox.
The AI value paradox.
Right. And to understand how to fix it, we first have to look at the architectural foundation these companies are currently building on. The core argument here is that the modern enterprise is trapped. They're relying on what the paper calls legacy SaaS wrappers.
Okay, let's break that down for the listener, because SaaS software as a service, that's the water we've all been swimming in for the last decade, right?
Oh, totally. It's everywhere.
It's the standard cloud subscription model. So why is putting an AI inside a SaaS wrapper suddenly a trap? I mean, shouldn't that just work?
Well, we have to look at how traditional software is fundamentally constructed. Traditional SaaS architecture is deterministic.
Meaning predictable.
Exactly. If a user clicks a button to generate a report, the software executes a very specific database query, retrieves a specific set of rows, and formats them into a predictable template. It operates on strict binary logic. A leads to B every single time.
Right, no surprises.
But then the generative AI boom happened, right? And companies scrambled to integrate these capabilities. They had to be fast. So the fastest, easiest way to do that was to take consumer-grade large language models, these massive generalized predictive engines, and simply wrap them in standard traditional middleware.
Ah, so they just bolted it on.
Exactly. They took a fundamentally unpredictable probabilistic engine and bolted it onto a rigid legacy system that is expecting binary inputs.
I want to pause on that word for a second. Probabilistic. Because for anyone listening who might not be, deep in the weeds of machine learning, an LLM doesn't actually know facts the way a SQL database knows facts, right? It's literally just guessing.
It is essentially the world's most sophisticated autocomplete. It calculates the statistical probability of what the next word or token should be based on the billions of parameters it was trained on.
Right.
So when you force that probabilistic guessing machine to communicate through legacy middleware that was explicitly designed to route predictable structured data, you create this structural friction.
Like trying to push a square peg through a round hole.
A very expensive square peg.
Mhm.
The paper calls these compounding liabilities.
And compounding liabilities in corporate architecture, that usually translates directly to compounding costs. I'm assuming one of those liabilities is just the raw expense of running the thing.
Oh, the primary liability is uncontrollable inference economics. I mean, in traditional software, computing costs are relatively flat and predictable. You rent a server, you pay a flat rate.
Right, the server just sits there.
Exactly. But with an LLM, every time the AI thinks, it consumes compute tokens. Every single token costs money.
So if it gets confused.
That's where the spiral happens. If you have an AI agent trying to navigate a complex corporate workflow through a legacy wrapper, and it encounters an edge case, which it will, it doesn't just stop, it guesses, it loops.
Oh, wow.
Yeah, it queries the API again and again, trying to statistically brute force a solution that the rigid middleware will actually accept. Those API costs spiral out of control instantaneously.
So a task that should cost a fraction of a cent suddenly costs dollars.
Dollars, plural.
Yeah.
And when you scale that across an entire Fortune 500 company, the budget just evaporates.
Because it's calling out to the cloud over and over, pinging servers, racking up a toll every single microsecond it spends confused.
Exactly.
And that brings up the second liability, which has to be speed. If it's looping and guessing like that, it's not moving fast.
Compounding API latencies, that's the second piece. When you have multiple specialized AI tools trying to coordinate through these legacy wrappers, the communication delay stacks up dramatically.
Because they have to translate everything.
Right. Traditional middleware requires data to be serialized, sent over a network, received, deserialized, processed, and sent back. When the data payload is this unpredictable tokenized output from an LLM, the error handling alone adds massive latency.
It's constantly checking its own math.
So basically, what should be an instantaneous machine-to-machine interaction takes seconds or even minutes. It completely destroys the promise of autonomous speed.
Which leads us to the third liability, and this is the one that really, keeps executives awake at night, the existential risk of hallucinations.
The big one.
The AI confidently lying to you. Now, if I'm using an AI to brainstorm a recipe at home and it hallucinates that I should add a cup of salt instead of a teaspoon, my dinner is ruined.
Right, bad dinner.
Annoying, but fine. But we're talking about enterprise deployment here. You can't just throw a cup of salt into a supply chain.
No, in a strict regulatory environment, a hallucination is not a funny quirk. If a financial AI hallucinates a decimal point in a capital deployment strategy, or if a legal AI hallucinates a compliance clause in a merger document,
that's a lawsuit.
It is a catastrophic, potentially existential threat to the corporation. Legacy SaaS wrappers simply cannot provide hard compliance guarantees because, again, they are fundamentally built on top of statistical guesswork. You cannot put a regulatory wrapper around a machine that is designed to guess.
So we've firmly established the paradox here. Bolting AI onto a legacy SaaS stack is structurally doomed. You can't patch it. You can't put more guardrails on it. The foundation itself is the actual problem.
The foundation have to be rebuilt.
Right. We need an entirely new operating system built specifically for the enterprise. And that brings us to the architects of the framework in this white paper, a company called Kategos.
Yeah, and the authors of this paper represent a major shift in thinking. Kategos actually recently rebranded from Arryn.Ai.
Oh, Arryn.Ai. I remember them.
Yeah. And that rebrand is highly significant because it reflects this deliberate move toward a boutique, strategy-led focus. They aren't just selling another chatbot interface anymore. They are filing foundational patents for a framework they term Categorical Intelligence.
Categorical Intelligence. That phrasing feels very intentional. Categorical implies absolute, definitive truth. It's basically the exact antithesis of probabilistic.
That is the exact intention. The goal is to completely abandon the ad hoc, chaotic deployment of AI copilots, the ones that are currently scattered across different departments in most companies right now.
Marketing has one, finance has a different one.
Right. It's a mess. They want to move toward a cohesive, centralized, and strictly governed infrastructure. And the beating heart of that infrastructure is what they introduce as the sovereign virtual operating system.
The sovereign VOS.
Yes, the sovereign VOS.
Okay, when you hear operating system, if you're like me, you immediately think of Windows or MacOS or Linux. Those systems manage my screen, my hard drive, my keyboard. They manage hardware abstractions. But the sovereign VOS isn't doing that, is it?
No, not at all.
It's operating on a completely different layer.
Standard operating systems manage physical hardware resources. Even most of the newer AI orchestration platforms, they simply rely on open source libraries to manage APIs and prompt chains. The Sovereign VOS is fundamentally different. It is designed from the ground up to abstract, schedule, and secure cognitive compute.
Managing cognitive compute. So it's not managing the hard drive, it's managing the actual thinking process of the enterprise itself.
Exactly. It sits as the definitive, impenetrable layer between all of a company's sensitive proprietary data assets and the various AI agents that are trying to reason over that data.
Okay.
And this brings us to a crucial architectural mandate. The Sovereign VOS operates entirely within a strict private cloud environment. It runs natively within the enterprise's own infrastructure.
This ties directly into the concept of Sovereign.Ai that the paper emphasizes so heavily. For anyone listening who manages IT infrastructure, this is massive. It means the system is not pinging a public, generalized server out in the world somewhere.
No. Sovereign.Ai dictates that the corporation completely owns and ring-fences every single asset.
Total lockdown.
Total lockdown. You retain absolute ownership of the data, obviously, but more importantly, you own the model weights.
Meaning the actual brain of the AI.
Right, the actual neural connections.
Yeah.
And you completely control the inference pathways. Nothing leaks out. If you are a modern enterprise building digital infrastructure today, exposing your proprietary logic and strategic data to public, generalized models, it's just an unacceptable liability.
You're basically handing your strategy to your competitors.
Exactly. Kategos makes the argument that adopting this sovereign categorical intelligence model is no longer just a neat optimization strategy for the IT department. It is a foundational requirement for corporate survival.
Okay, here is where I really need to push back on the paper's framework, because there's a phrase they use that I find incredibly provocative.
Which one?
The white paper claims that the Sovereign VOS models a company as a deterministic state machine.
Ah, yes.
Now, I love a good mechanical analogy, but a deterministic state machine implies a giant, perfectly predictable clockwork mechanism. If X happens, Y executes flawlessly.
Like a Swiss watch.
Right. But anyone who has ever worked in a corporate office knows that business is inherently ambiguous.
Sure.
Markets shift overnight, executives change their minds, people miscommunicate, goals are often just totally vague. How do you take a messy, chaotic, deeply human corporation and force it into a rigid clockwork translation without losing the nuance of a CEO's high-level goal?
That tension right there between human ambiguity and machine rigidity, that is the million-dollar question in enterprise AI right now.
Yeah.
And it is exactly where the architecture of the Sovereign VOS proves its value.
Okay.
The system doesn't pretend that human input isn't messy. It acknowledges the chaos. But instead of letting that chaos cascade through the execution layers, it treats messy executive input as programmatic intent.
Programmatic intent, meaning it takes a human directive like make us more money in Europe and literally compiles it into code.
It systematically digests that high-level ambiguous intent and compiles it down into incredibly strict operational constraints before a single action is taken.
So it pauses and figures out the math of the command first.
Exactly. The VOS operates as a hypervigilant manager for the AI agents themselves. It manages their entire life cycle, it tracks every microscopic change in their internal states, and crucially, it monitors memory boundaries.
What do you mean by memory boundaries?
It dictates exactly what an agent is allowed to remember from one task to the next and what it must immediately forget to prevent context pollution.
Wow. So it's not that the business world suddenly stops being chaotic. It's that the operating system acts like a massive, reinforced concrete funnel.
That's a good way to picture it.
You can pour this chaotic, rushing river of human ideas and market fluctuations into the top, but by the time it passes through the VOS, it has been forced into a perfectly controlled, measurable, deterministic stream at the bottom.
That funnel visualization is highly accurate. It forces chaotic inputs into structured, predictable pathways through a hardened, centralized pipeline.
Right.
But as soon as you establish that funnel, as soon as you rely on a state machine to execute your business, you run into a massive structural hurdle. For a clockwork mechanism to actually function without tearing itself apart, the gears have to be flawless.
The underlying data.
Yes, the underlying data that the AI generates and acts upon cannot have any errors.
Right. If one gear slips or if one tooth on the gear is misshapen, the whole clock jams.
Oh.
Which brings us to the core technical problem of this entire deep dive. How on earth do you force a fundamentally creative, hallucination-prone, probabilistic guessing machine to be a perfect, deterministic gear?
You have to solve the foundational problem of trust in deep learning. As we established, Transformer models, the architecture behind modern LLMs, guess the next word based on vast statistical correlations.
Right.
They do not have an internal concept of objective truth, nor do they operate on first principles logic. They are simply trying to generate text that sounds statistically plausible based on their training.
Which is fantastic if you want it to write a poem or brainstorm marketing copy or, summarize a long meeting. Plausible is totally fine for creativity.
Sure, it's great for that.
But plausible is an absolute disaster if you want it to validate a $1 million commercial contract or route physical shipping containers. You cannot use statistical guesses for a capital deployment.
Exactly why the Kategos architecture introduces its most significant engineering component to date. To bridge this gap between probabilistic generation and deterministic execution, they have engineered a patent-pending pipeline called the citation enforcement kernel.
The citation enforcement kernel, it sounds heavy. It sounds like something pulled out of a military aerospace manual.
Functionally, it operates very much like a military checkpoint. It is a multi-stage deterministic gate that sits aggressively over the neural network. To truly understand how this cures the hallucination problem, we need to walk through the exact mechanics of this pipeline step by step.
Let's do it.
Because it's a fascinating piece of software engineering.
I'm ready. Let's walk through the obstacle course. If I am a piece of data trying to get through this system, what happens to me?
The journey begins at the origin, which the paper refers to as the neural inference engine, component 104 in the diagram. This is your standard probabilistic AI generating a draft response to a prompt.
Okay, so it's doing its statistical guessing.
It is. However, within this specific architecture, the prompt engineering forces the model to predict citation properties as it generates text.
Wait, what does that mean in practice?
Meaning it doesn't just make a claim, it is forced to tag every single factual claim with a specific source ID.
Okay, so it drafts a document and says, our Q3 logistics costs in Berlin were $1.2 million, and then it immediately tags that sentence with, say, source document ID 492.
Correct. But at this stage, the system does not trust the AI at all.
Because it could just be making up the ID, too.
Exactly. The AI could easily be hallucinating both the 1.2 million figure and the document ID. So this is merely a draft. This brings us to the second stage. The interception.
The interception.
Yes. As those words, the individual tokens, are streaming out of the neural inference engine, a component called the metadata extractor, component 102, steps in. It literally catches the token stream mid-flight before it ever reaches a user interface or an execution layer.
So it's like catching the AI by the collar before it can actually hand its test paper to the teacher.
Exactly. It completely halts the output. The metadata extractor parses through that intercepted stream, specifically looking for those citation IDs and metadata anchors. It isolates them.
Okay, it pulls out the IDs. Then what?
Then we move to the most critical stage, the fact check. This is handled by the deterministic logic gate, component 108. This gate takes those intercepted IDs and runs incredibly strict referential integrity checks against a separate, highly secure database.
And what database is it checking against? Where does the ultimate truth actually live in this system?
It checks against the verified knowledge repository, component 106. This repository does not contain AI-generated summaries or probabilistic guesses. It contains rigid, mathematically verified source materials.
So it's the absolute, unalterable corporate truth.
Yes. We were talking about the verified general ledgers, the signed legal contracts, the official supply chain telemetry logs.
The actual lifeblood data of the company.
Yes.
Eh?
And every single piece of data in that repository has a universally unique identifier, a UID.
Right.
The deterministic logic gate takes the AI's draft claim and checks it directly against the UID in the verified knowledge repository.
So it's comparing the guess to the hard reality.
Exactly. And this is not a statistical similarity check. It is a deterministic binary check. Yeah. If the AI hallucinated the $1.2 million figure, or if it cited a document ID that simply does not exist in the repository, the logic gate caches it instantly.
It just blocks it.
It is a simple Boolean operator, true or false, match or no match.
Wait, think about the implication of that for a second. If I'm listening to this and I'm a compliance officer, this is the holy grail.
It really is.
It is essentially stripping the AI of its ability to lie. You're forcing it to prove its work against an answer key using deterministic code before the answer is ever allowed to be seen. You're basically using traditional, rigid software to act as a polygraph for the generative AI.
That polygraph analogy is highly accurate. But the architecture goes even deeper because it has to address a very specific, well-known vulnerability in neural networks. It has to solve the math problem.
The math problem. Yeah, if you spent any time playing with these massive frontier models, you've probably run into this. It's the bizarre reality that a supercomputer AI can write a brilliant, nuanced essay on macroeconomics, but if you ask it to count the number of R's in the word strawberry, or ask it to perform basic algebra, it confidently fails.
It fails miserably.
Why is that? Why are the smartest machines on Earth so incredibly bad at basic math?
It comes down to how transformer architectures process information through tokenization. They do not calculate math in the way a traditional calculator or a CPU does.
They just read the tokens.
Right. When an LLM sees a math problem, it breaks the numbers down into tokens, and it tries to predict the next token based on how often those numbers appear next to each other in its vast training data.
So it's treating numbers like vocabulary words.
Exactly. It is guessing the linguistic pattern of the equation, not computing the absolute value, which means they are notoriously, dangerously unreliable when it comes to strict mathematics.
Which is terrifying if you are trusting the system to run a corporate finance department. I mean, if it's guessing the linguistic pattern of your tax liability, you are going to jail.
Exactly. You can't have that. To completely insulate the enterprise against this structural flaw, the citation enforcement kernel includes a totally separate parallel component, the deterministic calculation engine, component 112.
A completely different engine.
Yes. This is an independent symbolic module. It does not use neural networks. It does not use machine learning. It is traditional deterministic code.
Standard software.
Exactly. When the metadata extractor detects a formula, a financial equation, or a structural value that requires actual calculation, it strips it out of the AI's hands entirely and routes it to this engine.
Oh, wow.
The engine computes the formula with absolute standard mathematical certainty and injects the perfect answer back into the token stream.
It takes the math homework away from the creative writer, gives it to a traditional perfect calculator, and then hands it back to be inserted.
Exactly.
That is brilliant compartmentalization.
It is the only way to guarantee mathematical grounding in a generative system. And only after the data has survived all these gates, the metadata extraction, the referential integrity check against the verified repository, the symbolic math calculation, only then does it advance to the final stage.
Which is what?
The data hits what Kategos calls the restricted output buffer, component 110.
The final staging area before it goes live.
Correct. But here is the critical action for corporate compliance. As the data sits in that buffer, the system generates a permanent audit hash and writes it into an immutable audit ledger, component 116.
Oh, so there's a permanent receipt of the whole thought process.
Every single verified state, every computation, every source citation is recorded permanently. It creates an unalterable history of the transaction. Only after that ledger is successfully updated does the system finally release the authenticated user output to the executive or the execution layer.
Okay, let's zoom out for a second and look at the macro-level implication of this kernel, because the white paper spends considerable time on the societal rationale here, and it is profound.
It's the most important part of the paper, really.
If you think about the trajectory the global economy is on right now, enterprises are rapidly rushing to plug autonomous AI systems into global supply chains, into shipping logistics, into high-frequency financial markets.
The automation of core infrastructure is happening at an unprecedented scale.
Right. And if those global systems are running on standard probabilistic models, meaning they are structurally capable of hallucinating at any moment, the risk isn't just that a single company loses a little bit of money on a bad trade.
No, the blast radius is massive.
If a major financial AI hallucinates a critical metric and triggers a cascade of automated sell-offs, or if a logistics AI hallucinates a fuel shortage across the eastern seaboard and reroutes thousands of cargo ships, global markets could literally crash based on a statistical artifact.
The paper argues vehemently that we cannot anchor the automation of our civilization to statistical guesses. The systemic risk is simply too high.
It's a house of cards.
It is. The citation enforcement kernel is presented not just as a corporate tool, but as a necessary societal safeguard. It mathematically eradicates systemic corporate misinformation at the source.
Because it physically won't let the lie out of the buffer.
Exactly. It provides the enforcement mechanism that the commercial world desperately needs to prevent data corruption from cascading through global networks. It establishes an unalterable standard for corporate truth.
So mechanically, we have solved the trust problem. We put the probabilistic AI through this incredibly rigorous multi-stage polygraph test, and it comes out the other side mathematically grounded and perfectly accurate.
Yes.
But, I mean, if I'm putting my IT infrastructure hat back on for a second, this sounds like an absolute nightmare for my server budget.
Oh, computing all of that is not cheap.
Running every single thought, every single draft, every single token through a multi-stage validation engine, intercepting it mid-flight, cross-referencing it against a massive database, running parallel symbolic calculations. That sounds computationally exhausting.
It is very intensive.
It sounds like it would require an astronomical amount of computing power. And in the AI era, computing power equals money.
You have hit on the second major architectural challenge. Once you solve for trust, you immediately collide with the compute crisis.
The energy bill.
The global AI energy crisis is not a theoretical problem, it is a current reality. The sheer volume of electricity and silicon required to run these frontier models is staggering.
Right. Earlier, we talked about the uncontrollable inference economics of legacy wrappers. If you are scaling a multi-agent ecosystem across a Fortune 500 company, and every agent is pinging a massive trillion-parameter foundational model for every tiny task, the API expenses alone will bankrupt you.
Right. If you use a supercomputer to write a summary of a 2-line email, you are misallocating resources on a massive scale.
It's overkill.
Kategos recognized that a secure system is completely useless if it is economically unviable, which is why the next core pillar of their architecture is the margin-based inference router component 204.
The inference router. I want to make sure the listener really grasps this because it sounds like a highly advanced traffic cop for AI brains. How does it actually work?
A traffic cop works, but the triage nurse in a hospital emergency room is actually a more accurate mechanical analogy.
Okay, walk me through that.
When a patient walks into an ER, the triage nurse evaluates the severity of the condition and routes them to the appropriate resource. The margin-based inference router does exactly this for cognitive workloads.
So it looks at the task before assigning the brain.
Yes. When a client, say, an executive issuing a command or another internal system requesting data, sends an execution request, it hits this router first. The router does not blindly forward the request to the largest, smartest, most expensive AI model available.
Which is what everyone does right now.
Exactly.
Okay.
Instead, it evaluates the marginal utility of the specific workload.
Marginal utility. How does it actually measure that? Is it looking at the length of the prompt or the complexity of the words? It's basically asking how much actual brain power does this specific task require?
Exactly. It analyzes the semantic complexity, the required context window, and the operational stakes of the request. Based on that evaluation, it dynamically routes the task down one of two primary tiers.
And what are the tiers?
The first tier is the efficiency model instance, component 206.
The efficiency model. So this is the smaller, narrower, faster brain.
It is optimized for low latency and low cost. This tier is explicitly designed to handle routine, high-volume administrative tasks, data validation, basic syntax parsing, formatting dates, or simple message passing between different software agents.
It is the administrative assistant of the system.
Precisely.
Right. I mean, if the task is check if this PDF document has a signature on page 4, you do not need a trillion-parameter neural network. You just need a fast, cheap model that knows what a signature looks like.
Exactly. The triage nurse sends the paper cut to the local clinic.
Love that.
But then we have the second tier, the performance model instance, component 208.
Heavy hitter.
This is the heavy-duty tier. High precision, high reasoning capability, and therefore very high cost. The router only activates this tier when it detects severe strategic ambiguity in the prompt or when a task requires highly complex multi-step reasoning demands.
Right. So if the task is analyze the geopolitical risk of opening a new manufacturing plant in Southeast Asia over the next 5 years, the triage nurse sends that to the neurosurgeon.
Precisely. But here is where the architecture requires strict scrutiny.
And this is exactly where I want to challenge the system, because I see a massive vulnerability here.
Lay it out.
If we are actively routing the easy tasks to a cheaper, smaller, narrower model simply to save money on compute, don't we risk losing all that rigorous fact-checking we just spent 20 minutes talking about?
I see where you're going.
I mean, smaller, cheap AI models are notoriously worse at hallucinating. They have fewer parameters, less context, and they get confused easily. If a chip model makes a mistake on a routine data validation, and that mistake enters the corporate workflow, doesn't that immediately corrupt the entire deterministic state machine? Aren't we just trading mathematical accuracy for a lower server bill?
That is the exact vulnerability that plagues most standard tiered model systems today. It's a great catch. but it highlights the most critical architectural detail in the sovereign VOS.
Okay, what is it?
The margin-based inference router dictates which brain does the thinking. Yes.
Yeah.
But regardless of which model is used, whether it is the cheap efficiency instance or the expensive performance instance, all results, without exception, still pass through the exact same citation enforcement kernel, component 210.
So the cheap model still has to take the polygraph test.
Every single token. Whether the thought was generated for a fraction of a cent by the efficiency model or for a full dollar by the performance model, it is intercepted, mathematically validated, checked against the verified knowledge repository, passed through the calculation engine, and permanently written to the sovereign audit ledger.
So it doesn't matter who generated it, the verification is the same.
Right. The bouncer at the door doesn't care how much you paid to get to the club. You still have to show ID.
That is incredibly elegant. I mean, you get the massive cost savings of using small models for 90% of your daily operations, but you don't sacrifice a single degree of mathematical grounding or regulatory compliance, because the deterministic logic gate catches the cheap model's mistakes just as effectively as the expensive model's mistakes.
It fundamentally alters the unit economics of enterprise AI. And again, the societal implication here is vital. The architects behind Kategos are highly focused on the environmental trajectory of generative AI,
Which is terrifying.
which, on its current path, is completely unsustainable. We literally cannot physically build enough data centers or generate enough electricity to run massive, generalized foundational models for every single corporate task on Earth.
Right, we'd melt the grid just trying to automate our expense reports.
Exactly. So by treating compute as a strictly scarce resource, by actively forcing the operating system to route routine workflows to hyper-efficient, narrow domain weights that operate locally, Kategos demonstrates a path to scale down the carbon footprint of enterprise automation.
It's green AI.
Essentially, yes. It proves that a corporation can achieve total digital transformation without endlessly burning through the global electrical grid. It creates a predictable, flat-cost architecture for the business while dramatically reducing systemic strain on energy infrastructure. It is a technological win-win achieved purely through smarter architectural routing.
Okay, if you are listening to this, take a breath, because we've just covered a massive amount of highly complex engineering.
A lot to take in.
Let's synthesize the components we have on the table right now. We have the secure private operating system, the sovereign VOS. We have the flawless polygraph fact checker, the citation enforcement kernel, and we have the cost-saving triage nurse, the margin-based inference router.
The holy trinity of this framework.
Right. We have essentially built the perfect, most secure engine possible, but an engine sitting on a workbench doesn't actually drive anywhere.
No, it doesn't.
What does it actually look like when you put this car in drive? What happens when these secure, efficient tools are unleashed to actually run the day-to-day operations of the business?
This is where the white paper moves entirely beyond the concept of chatbots or single-agent copilots. When you have an environment this secure and this efficient, you enter the realm of swarm orchestration, and you achieve what Kategos defines as the super agency.
The super agency. I love that term. It implies we aren't just talking about a single, really smart AI assistant living in a text box on your screen anymore.
No, the copilot era is completely over in this framework. We are talking about a coordinated, autonomous ecosystem of agent swarms. Think of it like a highly specialized, elite organizational structure where different departments of machine intelligence cross-collaborate autonomously to achieve massive corporate goals.
Okay, let's look at the mechanics of these swarms. How are they structured? Because if you just dump 100 highly intelligent AI agents into one giant digital room and tell them to run the company, they are just going to talk over each other. It would be total chaos.
Absolute chaos.
Yeah.
And highly susceptible to data corruption. To prevent this, Kategos enforces strict domain isolation.
Domain isolation.
Yes, each swarm operates in a highly specific ring-fenced silo, and is only granted access to highly specialized corporate data relevant to its function.
Give me a concrete example of domain isolation in practice. If I am the finance swarm, what does my world look like?
If you are the finance swarm, your context window, your entire functional universe, is restricted strictly to the verified general ledgers, corporate tax codes, financial proformas, and payroll data.
That's it.
That is all you know. You cannot see the marketing data. You cannot see the HR disciplinary files. Conversely, if you are the operations swarm, your context window only contains supply chain constraints, global shipping logistics, weather patterns affecting transport, and warehouse inventory levels. You do not know how much money the company has.
I can hear an IT director listening to this and screaming, why isolate them so severely? Isn't the whole point of a unified AI that it knows everything and can make holistic decisions? Why intentionally blind the agents?
Because if a single monolithic AI agent knows everything, the logic can subtly cross-contaminate during generation.
Ah,
You might have complex supply chain logic bleeding into a sensitive financial audit, creating a highly sophisticated hallucination that is incredibly difficult for even the kernel to trace. By enforcing domain isolation, the mathematical grounding of each unit remains exceptionally crisp. The finance swarm is only doing finance math. The ops swarm is only doing ops logic. It compartmentalizes the reasoning.
okay, that makes sense for accuracy. But a company only functions when finance and ops work together. If they're in their own isolated bubbles, how do they actually collaborate to get anything done?
They collaborate through a process called asynchronous synthesis.
Okay.
They communicate with each other via standard semantic protocols that are governed directly by the sovereign VOS and audited in real time by the kernel.
Let's unpack semantic protocols because that's a heavy piece of jargon. To use an analogy from earlier in our notes, a semantic protocol is essentially like a universal translator system at a United Nations meeting, right?
That is a very apt comparison, actually. The finance swarm speaks the language of spreadsheets, margins, and capital. The ops swarm speaks the language of shipping pallets, lead times, and fuel costs. If ops just yells, "We need more pallets to finance," finance doesn't understand the capital implication.
Right, it doesn't compute.
The semantic protocol translates the operational need, "We need 500 more pallets in Berlin,"
Yeah.
into the financial language. "We require a capital authorization of $5,000 for localized logistics." It allows them to understand each other perfectly without sharing their underlying databases.
Okay, I want to paint a vivid picture for the listener to visualize this asynchronous synthesis in action. Imagine you are that CEO again. You log into the Sovereign VOS interface, and you issue a high-level programmatic intent into the system. You type, "We need to launch our new product line in the European market next quarter, and we must maintain a minimum 20% profit margin across the entire rollout." You hit enter. What happens next? Instantly, parallel processing begins across the swarms.
Instantly, the strategy swarm immediately begins modeling corporate scenarios, analyzing European market penetration data, competitor pricing, and historical launch metrics.
While simultaneously, the operations swarm is evaluating the localized execution feasibility. It's looking at the real-time data and asking, can we actually get the physical products manufactured and shipped to warehouses in Berlin and Paris by next quarter? What are the current shipping delays at the ports?
And at the exact same millisecond, the finance swarm is building the economic projections. It is stress testing the CEO's 20% margin requirement against the raw logistical costs that the ops swarm is currently uncovering, factoring in European tax liabilities and currency exchange rates.
And they are all communicating back and forth through those semantic protocols. The ops swarm says shipping to Paris just got 10% more expensive due to a port strike. The protocol translates that to the finance swarm, which immediately updates the pro forma and realizes the margin just dropped to 18%. Finance signals the strategy swarm, which pivots the marketing spend to compensate, bringing the margin back to 20%. And all of this is passing through the inference router to keep compute costs down, and every single data point is being validated by the citation kernel to ensure nobody is hallucinating phantom budgets or fake mapping routes.
And this entire complex negotiation is happening at computational speed. What would normally take human departments 3 weeks of endless meetings, miscommunications, siloed email chains, and manual spreadsheet cross-referencing is executed by the superagency in minutes or hours with mathematically audited precision.
Wow.
It presents the CEO with a fully validated cross-departmental execution plan.
It is breathtaking to imagine a company running that efficiently, but I have to be honest, it also sounds a little terrifying.
Sure, it's a huge leap.
If you are a mid-level manager listening to this, or even a C-suite executive, and you realize the system is doing all the strategy, all the operations, and all the finance simultaneously, what does the human actually do? Are we just automating ourselves into total obsolescence? Are we handing the keys to the corporation over to the machine?
That is the central lingering critique of advanced autonomous systems, isn't it? The fear of losing operational visibility.
Oh, absolutely.
The fear that executives are forced to choose between slow, manual oversight or fast, unmonitored machine execution. Kategos recognized that a system that alienates its human operators will ultimately be rejected by the market. They solve this structural fear with their final major architectural pillar, The guided C-suite.
The guided C-suite. So this is how they maintain human-in-the-loop governance. The humans are still in charge.
Absolutely. The system does not operate blindly, nor does it define its own goals. The human executives define the core corporate KPIs, the operational guardrails, and the absolute risk tolerances. The AI swarms decompose those directives and run the predictive simulations, but they are strictly bounded by the human's rules.
Yeah.
They cannot invent a new strategy that violates the defined risk profile.
I want to introduce a mechanical metaphor here because it really crystallized how this relationship changes for me. Think about aviation.
Okay.
The executive in this new era is no longer the engineer down in the engine room, manually turning valves, checking pressure gauges, and shoveling coal. The executive is the pilot in a modern, fly-by-wire cockpit.
The fly-by-wire analogy is perfect. In a modern jet, the pilot does not need to manually combust the jet fuel or physically adjust the microhydraulics of the wing flaps every microsecond to keep the plane in the air. The autonomous fly-by-wire system handles the micro-adjustments perfectly.
But the pilot tells the plane where the destination is. The pilot programs the route. And if there is sudden, unexpected turbulence or a massive storm on the radar, the pilot looks at the instrument readings and decides whether to climb, descend, or reroute entirely.
Exactly.
The human makes the high-stakes contextual decisions. The machine handles the flawless execution of those decisions.
Exactly. And within the guided C-suite architecture, the sovereign VOS is explicitly designed to pause at hard-coded checkpoints.
Oh, it stops itself.
Yes. High-impact decisions like massive capital expenditures, legally binding contract commitments, or firing personnel cannot be executed autonomously by the AI under any circumstances. When the swarm reaches one of these checkpoints, the system halts. It presents the drafted execution pathway to the executive, and it requires explicit cryptographic human authorization to proceed.
And here is where the entire architecture comes full circle. Because of the citation enforcement kernel we discussed earlier, when that executive is sitting in the cockpit and is asked to authorize a $10 million localized logistics spend in Europe, they aren't just trusting a black box recommendation.
No, they have the receipts.
They can click on that number and instantly trace it back to its exact corporate data source. They can see the logic chain. They have perfect data provenance. They know the math is real.
They are making human decisions based on mathematically guaranteed certainties rather than statistical guesses. Which brings us to the final societal impact the white paper discusses. And it is a perspective I find incredibly optimistic, especially given the current anxiety around AI.
What's that?
They argue this architecture ultimately resolves labor alienation.
Right. Because the dominant narrative is always about AI stealing jobs and replacing humans. But this framework suggests a very different outcome for the workforce.
By implementing this highly structured, deterministic interface, the goal is not to replace human oversight. The goal is to free human capital from low-level administrative attrition. Think about how much of a modern executive's or manager's day is spent just hunting down lost data, verifying conflicting reports from different departments, or managing basic interdepartmental friction and miscommunication.
If you're listening to this and you work in middle management, you know the pain. Most of your week is spent doing repetitive TPS reports, formatting data, and chasing people for approvals. It's exhausting, and it's not what humans are actually good at.
The Kategos platform eliminates that attrition. The swarms handle the data hunting, the formatting, and the cross-referencing. By removing the friction of execution, it allows human leaders to focus their energy on what machines fundamentally cannot do. First principles, strategy, genuine creativity, human relationship building, and ethical leadership.
It elevates the job.
It elevates the human role. It makes the enterprise infinitely faster and more profitable while ensuring it remains strictly guided by human accountability.
It really is a complete paradigm shift for how a business operates. So let's pull all of this together and synthesize the journey of this deep dive.
Sound good?
We started with the AI value paradox. It exists because enterprises are trying to force probabilistic generalized AI into fragile legacy SaaS middleware, resulting in spiraling compute costs and dangerous existential hallucinations. You can't put a guessing machine in a rigid box.
And to resolve that paradox, Kategos has architected the sovereign VOS. By moving the entire infrastructure to a private, deterministic state machine, they successfully bridged the massive gap between the statistical potential of deep learning and the logical certainty required by a corporation.
They deploy the citation enforcement kernel, that multi-stage polygraph test and symbolic calculator to force mathematical truth, preventing global systemic misinformation and guaranteeing compliance.
They utilize the margin-based inference router, the triageners, to optimize compute loads, ensuring economic viability and actively solving the AI energy crisis.
And finally, they organize all of that secure, efficient compute into these brilliant asynchronous agent swarms, all operating under the strict guidance of a human pilot in the C-suite. It fundamentally alters the foundational economics and the speed of corporate intelligence.
It provides the comprehensive blueprint for what they call the categorical enterprise.
So if you are a leader listening to this and you're realizing that your own enterprise might currently be stuck in the legacy SaaS trap, if you are burning through massive AI budgets without seeing that deterministic return on investment, the white paper lays out a very specific, actionable next step.
It really does.
It calls for moving away from ad hoc chatbots and activating this new foundational architecture, which leaves me with one final provocative thought for you to ponder as we wrap up.
Let's hear it.
If the most powerful, dominant enterprises of tomorrow all operate as mathematically audited, deterministic state machines, if we successfully use kernels and routers to strip all the probabilistic guesswork, all the friction, and all the statistical hallucinations out of corporate operations, what happens to the inherent value of human intuition?
Wow.
In a future business world run by infallible agent swarms that can instantly calculate every single variable and model every single outcome with perfect data provenance, does a CEO's unquantifiable gut feeling become a dangerous liability that the system should ignore? Or, in a world where every company has the exact same perfect mathematical execution, does that deeply human, unpredictable intuition become the last remaining premium asset that artificial intelligence can never replicate?
A truly fascinating question to consider as we enter this new era.
Until next time, keep diving deep.
Relying on generic consumer LLMs wrapped in fragile SaaS middleware is no longer an innovation strategy. It is a compounding liability that exposes your enterprise to unchecked compute costs and hallucinations. True market leadership in the agentic era requires a strategy-first architecture that mathematically enforces data truth, stabilizes operating margins, and keeps executive leadership in firm command of autonomous swarms. Kategos has engineered the exact blueprint to turn your organization into a sovereign super agency. First, click the link in the show notes right now to schedule your 90-day sovereign activation audit with our advisory team to map your private cloud architecture. Second, head directly to our website to download the complete Architecting Categorical Intelligence white paper and examine our dual kernel technical specifications. And third, hit subscribe immediately. We have a series of high-profile enterprise visionaries and global tech titans joining us in upcoming episodes. Stop renting probabilistic tools. Start architecting sovereign intelligence, and remember that the future belongs to those who own the logic running their business.